Good morning, students, on this rainy Friday morning. This is your week in review. We had a big week this week, got a lot done. You guys did such a good job on all the labs and activities we did. So, to review some of the concepts, we were looking at electron placement on a periodic table. We were comparing some of the last group. Remember, if you're going left to right on a periodic table, and I'll show you this at the end, it's called a period. Up and down is called a group. We studied the halogens and noble gases this week. The halogens, including fluorine and chlorine, they're group 17 with 7 valence electrons. They're all about getting that 8th valence electron, so they're highly reactive. We also learned that they like to react with the alkali metals to make fireworks. So that's all fun. They use the salt to make fireworks. A little more complicated than that. Our noble gases, starting with neon and helium, they're group 18. They do not react. That is their chemical property. And we use those a lot to store more volatile elements, or even in lights, some of the ones that are in a classroom. We took a look at Lewis dot structures. This is more of a high school preview, but you notice that if this group has 1 valence electron, the outer shell of electrons is going to have 1 electron in it. This is group 2, your alkaline earth metals. Again, 2 valence electrons. Remember, we skipped the transition metals. They're a little more complicated. When we get to group 13, the boron group, 3 valence electrons, and so on down the line. So what can I do with this? If you take oxygen, for example, there are 6 dots around oxygen, 6 valence electrons. If I add 1 hydrogen, I have an incomplete atom. I need to add a second hydrogen, and that's how I can get H2O. So you can use this information to actually predict chemical formulas. But again, note your noble gases. These are full. The magic number is 8. They want to have 8 dots around them, and that this will dictate how things react. So all the things we were building and constructing this week had the same rules. You can only build things a certain way. Things can only bond a certain way. You can't just randomly throw this stuff together. And that was the point of a lot of things we were building this week. We also looked at exothermic and endothermic reactions. Exo meaning energy is going to exit. Endo meaning energy is going to enter. So if I'm cooking an egg, I'm melting something, I'm baking something, I'm giving it energy, so that's endothermic. Exothermic can be a little confusing because things like freezing are exothermic, but also fire could also be exothermic. As long as the energy is leaving, exothermic. So whenever I'm trying to classify, I always take a second and ask myself, is energy entering or is it exiting? And if I take that extra step, I can usually get these right. But I'm being honest, sometimes I get these two mixed up as well. It's okay. So this was kind of the point of everything. If you notice, this is a plastic molecule. You notice the carbon here has 4 lines around it. It can bond 4 times. We saw that in our Lewis dot structures. Hydrogen can only bond once. That's why you're not seeing any lines between the hydrogen. Every group has its own rules. Using those rules, you can figure out chemical formulas, charges. There's a lot of powerful things you can do with the periodic table. So we overall studied all the groups of the periodic table. So let's do a quick review. Here's group 1. These are your alkali metals, except for hydrogen. Hydrogen is there because it has 1 valence electron, but it is not a metal. Remember, these guys like to blow up in water. These are your alkaline earth metals, including calcium. They often form compounds and are used in a variety of ways, anything from milk to generating power. Your transition metals, this is 3 through 12. Now, these guys have 2 valence layers. They're your B group of elements. Remember, we talked about A group and B group of elements. So that's why these are a little more complicated, and we just kind of mention them, but it's not something we're going to study in detail in the 8th grade. Resuming with the A group elements, group 13 and up, there's a boron, carbon, nitrogen, and oxygen group. These all have very similar chemical properties as you go down a row. That's for everything you're going down in the periodic table. These are your halogens, and these are your noble gases. Remember, the 1 through 7 means that's how many layers of electrons that element has, and 1 through 18 will indicate the group number. 1 through 3 is 3 valence electrons. When you get up to boron, take away 10, and you get 3 valence electrons, 4, 5, 6, 7, and 8. Except for helium, which is still full, but it only has 2 valence electrons. Valence electrons are your outer electrons. They dictate how things are forming. So a lot of stuff happening this week. We're going to work on a gauntlet on Monday. I'll have an open Zoom. You can drop in anytime if you have questions. Tuesday, stay tuned for what's happening Tuesday. We're trying to put together a Veterans Day Zoom. If not, there'll be something happening when we get back on the 9th. We're starting adaptations, geologic time, fossils. It's fun stuff. There's dinosaurs. You'll like it. So we'll be starting a new unit when we get back. All right, thanks, and have a great day.